Şu an nasıl? Şu an geliyor değil mi? Yani bir saniye.
Ses geliyor. Merhabalar. Herkes sesimi duyabiliyor mu? Ses kontrolü yapmak istedim.
Sesiniz geliyor Numan Bey. Devam edebiliriz.
Tamam. Bütün webinar katılımcılarına ben göremiyorum tabii ama hoş geldiniz diyorum. TÜYAK'ın bu webinarına. Artık online webinarlara pandemiden bu yana alışmış bulunuyoruz. Yüz yüze gelmeyi de özledik aslında. E, Şimdi bugünkü webinarımızın adını hepiniz biliyorsunuz. Bir saniye. Evet, bugün webinarda yabancı bir konuşmacımız var. Kendisi çok deneyimli. Stefan Bühli, İsviçre'den. Bize damperler özellikleri, Avrupa standartları ve NFPA karşılaştırmaları konusunda bir sunumda bulunacak. Sunumunun sonucunda soru cevap kısmımız da olacak ve sorularınızı cevaplandıracak. Ben bir kısaca bu konunun önemine şöyle vurgulamak istiyorum. Hepimiz çok felaketle sonuçlanan yangınlar, bina yangınları duyuyoruz. Ve bu bina yangınlarında hayatların kaybolmasının önemli bir nedeni duman oluyor. Bu %90 oranında duman nedeniyle önce insanlar hayatlarını kaybediyorlar. Eğer kaçamazlarsa, kurtulamazlarsa. Tabii bunu önlemenin değişik ve değişik yöntemleri var. E, Yani mesela erken algılama sistemi de hayat kurtarıyor. Binanın departmanlara ayrılması yine hayat kurtarmak için belli güvenli alanlar yaratmak için önemli. Ve söndürme sistemleri var. Bunların hepsini farklı webinarlarda işliyoruz. Bugün biz bu departmanlara ayırma, kompartmantasyon dediğimiz departmanlara ayırdığımız, yangın zonlarına ayırdığımız binada birbirine hava geçişleri ve kanal geçişleri bulunuyor tabii ki. Buralarda kullanılan yangın ve duman damperlerinin hem Avrupa normları hem de Amerikan normları üzerinde farklılıklarını göreceğiz. E, Konuşmacımız Stefan Bögli, dünyada belki de konusunda bir numara olan ya da ben hani çok eskiden beri tanıdığım için liderlerden biri olan Belimo'nun kendisi 21 yıldır bir çalışanı ve ürün yönetim müdürü kendisi. Yangın ve duman damperleri konusunda da Avrupa, Orta Doğu ve Afrika konusunda da hem bütün müşterilerle ilişkilerini kendisi sürdürüyor. Çünkü kendisi bir elektrik mühendisi olmanın yanında aynı zamanda pazarlama, marketing konusunda da uzman ve 17 yıldır da benim çok özendiğim ama yapamadığım itfaiyede gönüllü itfaiyeci olarak çalışıyor. Bu konuda da kendisini çok tebrik ediyorum. Sözü kendisine vermeden önce belki dönen tanıtımdan arkadaşlarımız görmüşlerdir. Ama yine de kısaca bundan sonraki webinarlardan ben de kısaca bahsetmek istiyorum. Bunları da not alıp aklınızda tutup ya da notunuzu alırsanız sevinirim. TÜYAK 16 Mayıs 2024'te endüstriyel tesislerde yangın güvenliği eğitim seminerini Eskişehir'de verecek. 13 Haziran 2024 Perşembe günü ise acil durum yönetimi ve yangın güvenliği eğitim seminerini Konya'da verecek. Haziran 2024'te henüz kesin tarihi ilan edilmedi ama yine Haziran'da bir aktivite daha olacak. X-Proof çalışma alanları ve X-Proof sistem tasarımları webinarı olacak. Bunu da takip edebiliriz. İlk defa da bu sene sonundan önce 29-30 Kasım 1 Aralık tarihlerinde elektrikli araçlarda, lityum iyon pil, batarya sistemlerinde ve güneş enerji santrallerinde, GES'lerde yangın riski çalıştayı olacak Antalya'da. TÜYAK'ın bu etkinliklerinde takip ederseniz ve birlikte buluşursak çok seviniriz tabii ki. Ben kısaca tanıttığım konuşmacımız Stefan'a sözü veriyorum. Kendisi sunumunu paylaşacak ve devam edeceğiz. Daha sonra da en sonunda cevaplarımızı en sonunda alacağız sizden. Dear Stefan, floor is yours.
Okay, thank you very much, Numan. It's a great pleasure for me to have the possibility to speak to you all. I did that. I had the chance actually to do it. I think it's 4 years ago, before Corona. I could visit you in Istanbul, which was a very nice experience for me because I met a lot of very engaged people, very passionate people in the building industry, and a lot of them were very interested in safety in buildings. And this is also what keeps me going uh, to make buildings a safe place to live. Because when you look at today's life, if I look at my own life, for example, I would say in my working life, I spent 90% of my time in buildings, and every time I'm in the building, I'm supposed to be safe. But this is not coming for free, and safety in a building, especially also fire safety, is a big topic, and buildings are developing in different directions. Technology is going in different directions, and we should use them and use all these possibilities to make buildings safe. Okay, I will share my presentation. Let's see if that works. Okay.
It started. No problem.
Okay. Wonderful.
It's coming.
Yeah, I see it now.
Mhm.
Good.
You can make it full screen. Yeah.
Full screen, yes. Da-da-da-da. Oh.
It's okay.
Okay. Good. So I'm going to talk today about fire safety in buildings, some very general information. And as you know, I'm working for Belimo. We are a manufacturer of actuators. One range of that is specialized actuators for the motorization of fire dampers, of smoke control dampers. So we are a very small part in the whole safety business, but I like to give you a little bit a broader view to the safety business, and I would like to jump to have a look at the more European side, but also on the UL side. When we talk about safety, we very quickly talk about standards, regulations. This can be very top standards or regulations, but also very local standards and regulations. That's usually when I talk about it, I tell people, well, on the whole planet, the physics is the same, but when you look at how fires develop and how fire is handled, it's done very differently in a lot of countries, depending on the countries a little. And here in the first slide, you can see the difference when you look at the top level legislation. If we look at the blue part here, we see Europe, we see a big part of Russia, for example, as well. We mainly talk about CE standards, so the European standards. Also in Russia, although they have their own standards, the GOST standards, we do quite well when we sell products with the CE marking, complying to the CE standards, because these standards are quite similar to some extent. On the other side, you see a very big part of the world is the red part. This is the UL standards. Mostly they're applied UL standards. If you look to South America, I marked it red as well because most of it is also related to the UL standards. Some of the countries are also a little bit mixed. So European and UL standards. Middle East, of course, I'm also responsible with my team for Middle East. It's definitely a UL market, so it works more or less like the US. Other countries, for example, if you look to the Indian Pacific, India itself, it's a very mixed market. They have very local standards, which can also be very different. Some of the local standards, they take bits out of the UL standard, bits out of the CE standard. So it's a really mixed world there. In China and also France, you see the green part here. That's quite interesting. They have somehow a little bit of similarity because they require solutions, especially for the fire damper side, with very quick closing times. In France, they still use their NF standards, their French standards, although France is a European country. And in China, they have the so-called GB standards, which are Chinese standards. So this is a rough overview. When we look at buildings today, we see a trend. If you see here some examples, the buildings look more and more like design. They are design buildings. They are huge, especially the big ones. They look really fancy. What's also in common very often is that they are mixed-use buildings. That means it's not just an office building or just an apartment building. They are mixed use. It could be a big building, like an airport with a lot of shopping centers in it, maybe even a hotel integrated into the airport and things like that. So the use of the building is very mixed. That means also that the safety measures are getting more and more complex. One trend which can be seen for such building is that on the regulation side, it is not enough anymore to have like a descriptive fire safety standards, because this descriptive standards, they are quite how should we say, unflexible. They are quite stringent because they look at, for example, at a building which is an office building as an example, and there this descriptive standard describes very exactly what you have to do to be on the safe side regarding fire safety. But that's not possible anymore with today's building, because they're multi-use, they're more complex, they're designed buildings. So we see really as a trend, a shift in the standards going from the descriptive side to more performance and risk-based fire protection or standards. This means also that more and more engineering-based methods come to action when it comes to fire safety. So you design a system, you calculate the system, for example, you use CFD, computer simulations to verify your design. And then finally, before the building goes into operation, you do live fire testing or smoke testing, for example, if you have a smoke control system, for example. So there is a change going on, which we see more and more. Currently, for example, the Swiss standard for fire safety in buildings is under revision. And in 2026, we will have a new one. And the new one will really be very strongly performance and risk-based. So not prescriptive, descriptive anymore. Then just as basic information, if you look at the top standard or the top regulation in Europe, you quite quickly come across the European Construction Products Regulation, CPR. This is like the roof for construction products. And if we look to, for example, ventilation system with fire dampers, with smoke control, these products are regarded as construction products and fall under this regulation. That means this regulation on the high level has an implication for the damper OEMs, the manufacturer of the dampers. They have, on one side, they have the obligation to issue the so-called declaration of performance for their products. So if they deliver a fire damper as an example, this paper is mandatory that this goes with the fire damper. That means in this paper, you see all the detailed information. You see who was the manufacturer of this fire damper. You see a clear product identification. You see the relevant standards which these components apply, are conform with. Then you see the notified body which has done the whole testing of these components. And you see also the declared properties, like, for example, with which actuators has this component, this damper been tested with. So this is a very useful document, which really gives you a quick overview of what do you get when you buy this component, the fire damper. On the other side, they have further obligations. Another obligation coming from the CPR regulation is the OEMs, they have to issue an installation and operating manual, which also goes with the component. there you find guidance how to mount the damper into the wall, into the building, how to commission it, and then how to operate it, and also very important, how to maintain it through the lifetime of the damper or the building. This is a very important information as well. It also gives you guidance on how to use the damper, especially on regular testing, function testing, and this is mandatory information actually, which comes from the manufacturer of the damper. And there are further requirements which comes from this CPR regulation to the OEMs, but these are the very important ones. For the ones who are interested in this regulation, I put the link down here. So when you get the slide, you get also the link. It's downloadable from the European website. Now I come a little bit to the very basic. If we look at a building with a ventilation system, you see it here on the left-hand side. Small building with ventilation system. The ducts running in the different zones. If these zones, let's say this is a fire compartment, so we have firewalls, we have fire doors, and one of the main concept in a fire, there are many concepts or strategies in a fire, what to do in a building. A very important one is the so-called compartmentation. That means in case of a fire, the fire compartment, which is, for example, this one here, where you see the fire, you see a lot of smoke here in this compartment. The main target after detection of a fire is that you really close this compartment, keep it closed so that the fire and especially the smoke cannot distribute through the ductwork throughout the building. As Numan mentioned before, smoke is the killer, so it's really essential in a very early state in a fire, first to detect the fire and then close the fire dampers so that no smoke can spread throughout the ductwork to other sections, to other zones in the building, but also, for example, to close fire doors, etc. So all openings and keep the fire in this zone. So this is the first strategy. As you can see here in the duct, in the firewall compartmentation wall here, you find the fire dampers. It can be mechanical fire dampers, which just are triggered by temperature, like thermal fuse, but it can also be motorized fire dampers. If I look to have a view to Europe, then I can say, okay, in Europe, roughly 50% of the fire dampers are motorized. I think this is still quite a low number, because if you have non-motorized, just mechanical fire dampers, you can imagine it takes a lot of time until up here, somewhere in the ductwork, you see higher temperature. Even if you have here in the middle of a room quite a developed fire, temperature can still be at a lower level, and the fire dampers can still be open. That means you're still able to distribute a lot of smoke throughout the building. And this is, of course, the big advantage when using motorized fire dampers. You can react early in a fire, close them after reception of or detection of smoke. And this means you really protect the people in your building, but also your assets in the building at a very early stage. So you can minimize the damage. What's also important to mention here, if you look just at the fire damper, which you see here on the right-hand side, there is one safety position of a fire damper. It's always the closed position. Shutting off the respective fire compartment, closing the damper and blocking the transfer of smoke or fire through the ductwork. So it's always closed position, and that is also the reason why always spring return actuators are used on fire dampers. So spring return closed. If we look at the second strategy, which can be used in a fire, it's smoke control. The main target of smoke control is keeping escape and rescue routes free of smoke. So for a certain amount of time, of course, so that really people which are still in the building can safely and without smoke walk out of the building. This takes some time, depending of the building, of the construction of the building or size of the building. This can be quite a big time, which is needed to evacuate. But also on the other side, it supports in a high degree the fire brigade, which goes into the building. So it's really a useful installation. Here you can see a little bit a different philosophy. Point number one is, or thing to remember is, number one is that it is, as you can see here, it's marked green. It's a separate system from the ventilation system. This is really special. This is regarding the European standards. It's a must to have a separate system. According to European standards, it's not allowed to do some sort of smoke extraction via the ventilation system. What is the reason? The design of the system is completely different. Design of a ventilation system is more towards air quality in a building, and the design of a smoke control system is clearly towards smoke extraction. And smoke means you have a high volume. It's a very high volume thing, and its smoke is also hot. So you can really extract hot gases via the smoke control system. This is why it's a separate system. It can be very efficient, and you see here the damper construction looks a little bit different. I come to a later point to some details. What's special is that the smoke control dampers, they have two safety positions. It can be either the closed position, as you see here, in the adjacent zones to the fire zone. Here you hold the dampers in the closed position because you want to prevent smoke coming in to these zones. And here in the zone where the fire is, you see here the safety position is the open position. And also here you have smoke extraction damper here, and you have also a smoke extraction damper here, but this damper here is for letting fresh air into the zone. And then usually you have a big fan somewhere on the roof or on the side of the building extracting the smoke. So what's also in the European standard is that for this application, for the application of smoke control dampers, only non-spring return actuators are allowed. So this is really defined by the standard. This is the big difference here. A little bit a closer look, fire dampers. As I said, safety position is always closed. Spring return actuator, it's not a standard spring return actuator which is used. It's really a very dedicated design of actuator for the fire dampers because it usually has some sort of thermoelectric tripping device, as you can see here on the damper. This is the primary safety element. That means the latest point, if he sees here some temperature, it will trigger the actuator to spring return the damper to the closed position. But of course, if you have a little bit more intelligent building, your fire alarm system, you trigger the actuator by the smoke detection system. It's also very important to note this thermal tripping device here. It's mandatory by the regulation, and it must be of non-resettable type. It's not allowed to use here some resettable type of thermal fuse. Then on the smoke control dampers, the safety position is open or closed, so two safety position. That's the reason why no spring return actuators are allowed. And the smoke control system is always triggered by the fire alarm system or smoke detection system. And no tripping device a thermal tripping device is allowed on the dampers. This is also coming from the standard. Doesn't make sense because you detect the smoke and then you start very early on detection of the smoke, you start the smoke control system. Maybe you see the damper construction here. What comes to your eyes maybe is that you see, okay, here is the damper. It looks like an insulated damper. Also here, it looks like an insulated damper. Here, the whole damper is insulated. Also, the actuator is insulated. On the smoke control side, this can be a little bit different. But as an example, I go to the fire damper. And by the way, I almost forgot. Very important note. The damper together with the actuator is always a certified component or unit. So the fire damper manufacturer, he mounts our actuator as an example on his dampers. And together with this unit, the actuator and the damper, he goes to the certification process. That means life cycle testing, that means fire testing. So it's a certification thing. That's very important to know. Regarding certifications, I put you here the standards for the fire dampers. On the European level, we have 4 standards. One is the product standard. It tells you, oh, what is a fire damper, where to use it, how to implement it, things like that. And then he refers to the other standards where you find the test standard. How is this unit tested? This means mainly cycle testing, fire testing. And then also you find the classification standards. You find different classifications for these dampers. I come to that point to give you an example. And then is the so-called extended application standard. This is quite a new one for the fire dampers. This standard explains, for example, what you have to do as a manufacturer when you change something on the damper, for example. You use another brand of actuators, for example. So what do you have to do? You have to go for another fire test, for example. If you do some technical change, like you change your linkage type or you change your sealing on the damper, you find the guidance in this extended application standard. What's also in there is some implications regarding multi-damper assemblies, etc. So if you put together more than just 1 or 2 dampers. On the smoke control side, you see quite a similar picture. So the structure is the same actually. You see the product standard again, giving you some clues what is a smoke control damper. In this product standard, you find also different application of smoke control dampers because there are 3 different applications mentioned in there. You find as well the test standard and the classification standard for smoke control dampers. What's missing, you see it on the slide, is the extended application standard. This standard is currently on the CEN level, on the European Commission level. It's currently under discussion if work on this 4th missing standard should be started. I hope they will start it because it gives great help for the manufacturer of the dampers. Good. talking about classification, I just would like to give you a quick example classification of how a classification of a fire damper looks like. I mean, there are three very important characteristics of a classification. One is the criterion E, which is a fire resistance integrity of the damper. That means how long can the damper withstand a fire? And you see it here on the whole naming here, E120, this is the duration in minutes. And usually you find ratings like E90, E120. These are the most common ones used in Europe, but they're going up to 240 for very special applications, for example, in the marine business. So this is the first criteria, which is very important. Then you see the E, which the E, yes, which stands for insulation. That's the insulation of the damper plate. In Europe, most damper are E-types, so insulated dampers. Very, very rare dampers are still non-insulated dampers, so metal sheet dampers. But when you go, as an example, if you go to the UK, most of the UK dampers today are still non-insulated dampers. This is from historical reasons, but currently there are big discussions in the UK regarding switching over to also insulated dampers. So we see some changes in the market there as well. And the S criteria is for low smoke leakage. So this is for really very low smoke applications, but this is also more or less becoming a standard. So most or a lot of the dampers, the bigger part of the dampers built into the buildings are AES dampers today. If you have a damper, if you look at the damper, go to the declaration of performance, you will exactly find the classification of this damper in this paper, and you exactly know what you get. This is why I really like the declaration of performance. Little bit aside information, what do we also see like a trend in the market? If we look at the buildings, it started many years ago that the systems, the control systems for fire dampers or also smoke control dampers, they are more and more go to bus systems which are used. This is just an example. This is how it would look today with our solutions. But in the future, it will also go to actuators with integrated bus interfaces, and this allows to have really very efficient installation. It makes installation much easier than today, and especially it offers the advantage which you see here on the downside of the slides. So it's easy to do periodic automatic testing of such installation, and you get a direct feedback from all the dampers on the status of the damper. And of course, less wires in the building is also less fire load in the building, and that's also criteria. Because if you look at all the wiring which you have in the building, if you have a fire and the wires are burning, you create an additional lot of smoke. And also in the introduction, Numan talked about testing, regular testing, on cycling the system. This is a very important thing. Here I try to show the difference between motorized fire dampers and non-motorized fire dampers. You can see it here. The non-motorized fire dampers is the red line, and the motorized fire damper is the blue line. And on the graph, on the vertical axis, you see the risk which is implemented, and on the horizontal graph you see the time. So usually after commissioning you have like 2 6-month cycles where you have to do an inspection, usually on site. That's in most countries it's like this. And then after 2 successful periods of 6 months, you can expand this cycle to 1 year. So annual visual inspection is quite common. And you see during this half a year or 2 cycles of half a year or 1 year period, the risk can go up quite high, because on the mechanical side, you don't know what the situation is in the damper. You cannot remotely test it. So you don't know how the status is of this damper. So the risk goes to some sort of level. And then after 1 year, you go there, check it again, and then you know, okay, everything was good, or oh, it wouldn't have worked in a fire because it's jammed or there is some dirt in it or something. And on the motorized side, you have the advantage. You see it here. You can operate the damper, let's say once a week, once a month, whatever. And then you always get a feedback. You get a feedback. Okay, damper is open, damper is closed again, or open again, and you have this feedback, and you know, okay, the damper is still moving. Actuator is okay. Damper is moving. So the risk is a little bit differently. You still have some risk that something could be wrong, the sealing couldn't be that good anymore, and things like that. But you get some feeling, and the risk level is a lot different, a lot lower, as you can see here. So you run your system on a lower risk level without going there actually. And then after 1 year, you go there and then you see, okay, it's still working. So this is a philosophy, and this also lets me say or give the advice which I say not only to fire dampers or to any safety system actually. Whatever system you have, safety system, you use it on a regular basis, because then you know it's working or it's not working. And usually I often compare fire dampers also with fire doors. The fire doors have one big advantage. You walk through the door several times a day, and each time you walk through the door, you open it, it closes. It's like a test. So you use it on a regular basis, and you can be quite sure that the door is working if in case of a fire. And if it's not working, hopefully the guy walking through the door, he realizes, oh, the door is not closing correctly. I report this to the facility manager. Unfortunately, the fire damper has the same function as the door, but it's not visible because the fire damper is hidden somewhere under the ceiling, but has the same functionality. So regular testing is a really big advantage. And by the way, who is responsible for maintaining the installation, for regular testing, for inspection on a regular basis? It's the building owners. And very often, unfortunately, the building owners are not aware of their responsibility. So it's also an important point that the building owners are made aware of their responsibilities. Now, let's go to the UL side. Of course, it's a big topic in Americas, but since I'm responsible for EMEA, I look to the EMEA countries. You see here a small list of some of the countries. They are mainly UL focused. Israel is a little bit mixed. Sometimes they say, yeah, we are now more CE. Sometimes they say we are more UL, but it's a little bit mixed. If you go to the NFPA website, you find a lot of information regarding the UL world. I think a lot of people on your side know also this website. So I took this picture from their website. You see where fire dampers are installed, for example, smoke dampers, or also combination dampers could be installed. They give some guidance. When we look here on the dampers, the picture is a little bit different from the European side. You see the fire dampers according UL 555. Fire dampers are almost non-motorized. Very often they look like this. This is a so-called curtain dampers. It's like a jalousie coming down here. There is a tripping device here, a mechanical part. If this part sees temperature, it just releases the shutter here, which falls down. This component is reacting very late in a fire unless you have very high temperatures from the beginning, which you seldom have actually. So it does not prevent the distribution of cold smoke in the initial phase of a fire. So people must be aware of that. Then the second type of damper, which is used quite often, is so-called smoke dampers. These are referenced to the standard UL 555S. S is for the smoke. You see it here, it's a different construction. It's a motorized construction. They are sometimes made of steel plate, of steel, but also of aluminium. They have the duty to prevent the spread of smoke. So they have a limited leakage rate, etc. And then we have the combination of both, the so-called combination fire and smoke dampers. They refer, of course, to both standards, UL 555 and UL 555S, because they incorporate both functions. They have an actuator and they have also so-called heat responsive device or a thermal tripping device. Sometimes it's just incorporating one tripping temperature, but it could also be a secondary device with a different temperature. So in the fire, the first element will trigger the damper to the closed position, so it has a fire damper functionality. But then the fire brigade could over control it to reopen the damper, and then on reception of a second temperature level, usually a higher level than the first one, then the damper will close again, and then you're not able to control it anymore. So in initial state, the fire brigade could operate this damper, let's say for trying to clear some smoke via the ventilation system. If we look at the standards, it's also there are also NFPA standards in place. There is mainly the NFPA 80 regulates the fire dampers. It explains the requirements of regarding inspection and testing, and it outlines as well the maintenance and repair requirements. You can find the same for smoke dampers, which is NFPA 105. It explains also the inspection, testing, and maintenance requirements. And of course, for the combination fire smoke dampers, you have to comply with both the above standards. And there is another one, is so-called the NFPA 92, which regulates dedicated smoke control systems. So there is a separate standard for that. But today, when we look at the installation of the combination dampers, combination fire smoke dampers, only roughly 15% of these dampers are installed in the smoke control systems. So very often it's done via the ventilation system, and the part or the numbers of the really dedicated smoke control system is still quite small. Also, when we look at the UL world, it's becoming more and more a topic. What I showed you before is the whole bus integration, and especially the remote testing, which is made much more easy because it can be automated then. And remote testing was enacted by NFPA in 2018. So already 6 years ago, they put it also in the standard as a possibility to do a regular testing, which is good. So also here, the regular use of the dampers becomes more and more a topic. What's a little bit strange, in my opinion, when you look at the UL standard, you see the frequent testing or frequent inspection, excuse me, requirement is every 4 years, or sometimes, especially in hospitals, it's every 6 years, which is a little bit strange. Okay. Here I like to summarize the comparison. You see the UL standards on the left-hand side, the CS standards, as I showed you, on the right-hand side. Then you see some of the differences. You noted that on the UL side, fire dampers are always metal sheet dampers, non-insulated. They have a fusible ring, non-resettable. They are made, there are different types of fire dampers for static or dynamic systems. That means static systems, you have to switch off the ventilation system first, and then the damper closes. And dynamic system, the dampers can close during the operation of the ventilation system. That's also special. That's something we don't have on the European side. You see on the European side, fire dampers, you have most of the dampers are insulated plate dampers. The tripping device is non-resettable as well. By the way, you see here the standards for the tripping devices. It's UL 33, and on the European side is the ISO standard. What's also special is here on the cycles. Cycles for fire dampers is 10,000 cycles or 20,000 cycles, depending a little bit on the application. Then on the smoke dampers, you have also here on the UL side, non-insulated metal sheet dampers, 20,000 working cycles, smoke control in Europe. You have insulated dampers, no thermal tripping device allowed. And here you usually have 10,000, 20,000 cycles. And then the combination dampers, it's a little bit a mixture. Metal sheet dampers, electrical heat release devices, resettable devices. That's the big difference here. You can reset one device at least, and 20,000 working cycles. Yeah, that's it from the comparison side. I put you some links in here. You find a lot of additional information when you go to our Belimo website. You find a lot of information regarding the European world. If you go to our US website, you find a lot of information from the UL world. And of course, I added the link to my Turkish colleague in Istanbul, so you can refer to them. They speak the same language as you do. So don't hesitate to ask them for help. And now you know if they have no answer, I'm the backup from my colleagues in Turkey, and I will support you as well, of course.
Thank you.
Then I
Thank you very much, Stefan.
Thank you. Then I come to the end. I have one question before you can ask me questions. What's the thing on the left-hand top corner?
I will not answer, but I will wait for our, attendance to make a guess. Okay.
Okay. Okay, then I hand over back to you, Numan.
Thank you very much. Değerli katılımcılar, bu son slayttaki sorusu bu cihazın, görünen sol üstte görünen cihazın ne olduğunu soruyor. Tahmin edebilen var mı? Bakalım. Burada soru cevap kısmında göremiyorum. Bu ben cevaplayayım. Bu benim onun ilk yapmış olduğu yangın damperi. Damper motoru, daha doğrusu damper motoru, yanlış söyledim. When was it? I don't remember this first damper motor was made.
Exactly.
Yeah.
You are right.
1978, yes, okay.
Yeah, 1978. So 3 years after the foundation of Belimo, they introduced the first spring return actuator on the European market. And this actuator was also the first actuator mounted on fire dampers. And the fire dampers was the manufacturer was a Swiss company. It's called Hesco. It's still here today. It's quite close to Belimo in Switzerland. Today the company is called Trox Hesco.
There are some questions.
Good.
There are question and answer chat box over there. Some of them in English, some of them are in Turkish. So I think our translator will translate it to you. Or should I translate?
Okay. I can see. Let me see if I can see the chat box.
The first question is that, can you please share the presentation to the attendees?
Yes, of course.
I think it will be shared by TÜYAK.
Yeah. I send you my latest one. I did some minor change, so you can distribute it.
Okay.
Yeah. I think you will also translate it, right? I don't know.
If necessary, it depends on TÜYAK. If it is necessary, then I can help for that. Okay, Ms. Şengül is also writing an answer to this question. The other question is that, can you explain difference between multi-compartment and single compartment smoke dampers?
Yes. Single, that's a good question. Okay, I try to explain it without picture. A single compartment is, for example, if you have a smoke extract ductwork in a room, and this ductwork is going directly to the outside of the building. So this is single compartment. Multi-compartment means that you have, let's say, 2 rooms, one room on the left side, one on the right side, and there is a duct running through both rooms, and then it goes outside to the building. And on the room, in the room, you have the single compartment on the room where the duct goes to the next room, and then actually the duct goes through a room and outside of the building. And the second room must still be safe. If the single compartment is on fire, you go with the smoke out of the single compartment, through the duct in the multi-compartment, and then outside of the building. So you have to cross one room within the duct. You have to have the hot smoke, and you have to make sure that you're still safe in this second room. So in this second room is called multi-compartment, because there you have special requirements on the ductwork, but also on the smoke extract dampers which are installed in this room, because you shouldn't see any smoke. If you like to have more information on that, then you should go to the product standard of the smoke control dampers 12101-8, And there you find this this description, and you find also some examples, some pictures in it. And then you see multi-damp, single compartment and multi-compartment zones in it, and the respective requirements to the ductwork, but also to the dampers.
May I add you a question about the damper motors? Are they all the standard damper motors for the single and also multi-department, or is it only question of the dampers and the ducts?
It's the same actuator, which are not standard HVAC actuators. So it's a dedicated actuators for fire dampers, dedicated actuators for smoke control dampers, but it's for both applications. It's the same actuator. Yeah.
Ben kısaca Türkçe şunu söyleyeyim. Tek zonlu olan yerde, sadece dumanın dışarı atıldığı yerde, tek bir damperden çıktığı zaman single, yani tek kompartmanlı diyoruz. Ama yangın duvarını geçip de kanal, ikinci bir odayı, kompartmanı da geçip ondan
Yeah.
sonra dışarı atılıyorsa multi dediğimiz, yani daha fazla odanın olduğu durumda, tabii o zaman
Exactly.
da
Yeah.
kanalın da korunması gerekiyor ve
Yeah.
özel damperlerin de buna uygun olması lazım, test edilmiş olması lazım. Ama motorlar, benim ilave sorumla, motorlar aynı damper motorları kullanılabiliyor. Fakat bunların için özel böyle bir departmanlaşma varsa bunların tasarımıyla ilgili kaynaklara gitmekte, üretici manuellerine bakmakta fayda var. Teşekkürler. Thanks. Now let's go to the next question.
Yeah.
This is about the pressure relief dampers, but this is a little bit out of our scope of webinar today. I think this is coming from Bayram Metin. I would like him to raise this question to us later, and then we can also answer this.
Okay.
So, from Mr. Seçkin, Tuncer Erdoğmuş, spring return actuator. So, question is very short. Spring return actuator. You mentioned that when you need spring return, when you don't need spring return. Do you want to add something else?
Well, it's what's in the standard that's maybe interesting when you talk about spring return. You always talk about spring return when we talk about one safety position, so the fire damper. The standard itself, it doesn't say it needs to be a spring. It could, for example, also be another solution like supercap, which is like an electronic battery storing energy and controlled standard damper in the closed position. That would be also allowed. But up to now, there are not such solutions on the market. But the spring, it's really a very proven solution. It's a mechanical thing, but it shows something which is very important, maybe, that a standard or a regulation never should dictate a technical solution.
That's clear. Mr. Seçkin also corrected that. He answered the picture. It was for the answer of the picture quiz. Okay.
Okay. Okay. Okay.
Okay. So,
okay.
If you don't see the questions, I read it.
Yeah, I don't see it.
Hi, Stefan. I would like to thank you for first for the presentation. I have a question. I know it is not mandatory to monitor fusible link dampers according to EN. What is the situation in NFPA? It is not mandatory to monitor fusible link dampers according to EN. So only fusible link They are manual. You don't monitor them in general.
No, in
And
general, not. If you look to the UL world, maybe I go back, you still see, I think you still see my slides. If I go back to the fire damper UL 555S, the curtain damper, it's purely mechanical. There is no electrical installation going to that damper.
yes.
There
And
are some installations in Middle East, but they are more multi-damper blade fire dampers. Sometimes they have an electrical switch in the close position, but
so,
not very often.
yeah, so it is not mandatory.
It's not mandatory.
Okay. Duman sensörü olmayan yangın damperlerinde motorlu duman damperlerin sigortalı duman damperlerine göre avantajları nelerdir? Üzerinden tekrar biraz daha detaylı geçebilir misiniz? Teşekkürler. So the question is that if the fire dampers, I don't know if Miss Şengül Hanım already translated or not.
I'm not sure if he is talking about the European solution or the UL solution.
Mert Bey, burada duman sensörü olmayan yangın damperlerinde derken duman sensörü olan zaten duman sistemlerinde algılama sisteminden kontrol ediliyor. Açık ya da kapalı olması gerektiği senaryoya göre. Duman sensörü olmayanlar sonucunda yangın damperi olarak çalışıyor.
Ah, yeah.
They work as a fire damper, but not a smoke damper. So smoke dampers, the question is that if there is no smoke sensors, detection sensor,
Yeah.
is there any solution for that? But all the smoke dampers are working according to the fire alarm panel, depending on the smoke detector. Is that correct?
Yeah. So on the smoke, when we talk about smoke control solution, which is a separate system, you always have a smoke detection system in the building, always.
Okay.
Sorry. On the fire damper side, you see everything, of course. Sometimes you have a fire alarm system, smoke detection system. If you don't have one, then you have two possibilities. One possibility, you can put a smoke detector right in the ductwork, somewhere near the damper, for example, or in a zone, just controlling this zone, for example, closing the dampers also via electrical signal, or use the primary safety element, which is the thermal fuse here. So this is mandatory. So to monitor temperature in the zone is mandatory. So this fuse is always there, but not smoke detection.
Okay, I think this is clear. Another question, Belimos future high torque actuator for fire dampers. It announced in 1920. Is this? Sorry. It announced in June 2023. How is it going? When it will be released? Belimos future high torque actuator for fire dampers.
Yeah,
There's a situation for that. Yeah.
That's a good question. This actuator is coming beginning of 2026.
Long-term testing, I think, and working on it.
It's designing. Yeah, we're in the designing process, and also, of course, designing not only the actuator but also the respective assembly plants.
Okay. Bu 2026'da geliyor. Bunun cevabı bu. Smoke control dampers, actuators must be only open close or could be modulating type. The question is that did you get it? Smoke control dampers, actuators are only open close or can be modulating type?
It can also be modulating type. Modulating type can be seen since a couple of years. You find them, for example, in underground car parks, because in underground car parks, you have two possibilities. You have to use a normal ventilation system and a smoke control system. But very often you use just a smoke control system, and this smoke control system is used for smoke control, but also CO2 ventilation.
Mhm.
But the design of the system is really for smoke control purpose. And there, when you use it for normal operation, then you can use the smoke control dampers also as balancing dampers. And this can be seen more and more coming because it's a cheaper solution than two systems.
Well, this is good input, I think, for me too. It's good.
Good.
Yeah. Now, Şengül Hanım tercüme ediyor olabilir. Did you get the question?
That's a very good question, because just to start with an example, in Switzerland, the legislation giving authority is the organization of the building insurance companies in Switzerland. So they are issuing the fire safety standards for Switzerland. And that's exactly because they want to have control over fire safety in the building. And that's by the way, also the reason why Switzerland is 100% motorized when it comes to fire dampers, because it's an obligation from the insurance companies. But when you look at other countries, of course, if you have a fire in a building, the insurance company, they will look at all your documents regarding maintenance, etc. And they want to see your protocols of your maintenance, which you have to do periodically on a certain rhythm, like annually, for example. And if you cannot show these documents, you will have a problem. If it's obvious that the installation was not okay due to some reasons, maybe some screws looking into the duct preventing the damper from to fully close and things like that, and this really happens in the field, then of course they will never pay the full insurance amount. So they are very good in spotting such things, non-compliance when it comes to an incident. And that's also depending on the countries. It's also that the legislative authority, they do regular checks in the building. So they come to your building and want to see all the maintenance reports. And sometimes you are also obliged to do every X years, for example, so-called integral testing. That means a full system test, especially also if you do some refurbishment work. That means you change something in your building, put in another wall, or knock down an existing wall and make a room bigger, for example. Then you have to do a system test. That means you have to trigger the smoke detectors and see that the fire dampers close accordingly to your control plan, etc. And this all this work has to be documented, and you have to be able, the owner has to be able to show that to the authority, which also could be the insurance companies.
I would like to add something in Turkish for the audience, okay? For this,
Sure.
You will also hear in English, I think. I have to switch now. Şimdi bu test, daha doğrusu yangın damperlerin izlenmesi konusundan ve testlerin daha sık olması konusunda bir slide görmüştük biliyorsunuz. 6 ayda 1 senede olacağını ve riski yüksek yapacağımıza, bunun bir kontrol sistemiyle, yani bütün yangın damperlerini ve duman damperlerini izleme sistemiyle, ki bunun bir otomasyon sistemleri var. Piyasada da var bunlar. Ve bunlarla çok daha sık izlenmesi ve raporlanması çok önemli. Bunlar da tabii ki yangın damperi temin eden hem kuruluşlar, hem müteahhitler, hem de işletmeciler, bina sahipleri açısından özellikle de ölümlerin %90'ının dumandan olduğunu söylediğimiz için bu tür raporlaşma çok önemli. Onun için de bu binalarda tüm yangın ve duman damperlerinin izlenmesini ben de tavsiye ediyorum. Bunlar bina otomasyon sistemi ya da bina yönetim sistemi, Building Management Systems dediğimiz sistemlerde gözlenip raporlanabilir. Bütün bunlar sigorta şirketlerine karşı veyahut da üçüncü şahıslara karşı bir can ya da mal kaybında sanıyorum koruyucu olacaktır. Bina sahiplerinde, üreticileri de. Bu konuda ben ısrarcı oldum ama Türkiye'de çok az uygulanıyor bu tür sistemler. Avrupa'da %50 binada olduğunu söylemişti Stefan. Ama Türkiye'deki oranı bilmiyorum gerçekten. Ama iş hayatım boyunca gördüğüm kadarıyla %0'a yakın ya da çok az. Bu konuda da dinleyicileri projelerinde tekrar bu konuyu değerlendirmeleri için katkıda bulunmak istedim. Teşekkürler. Başka soru var mı? Elektrikli araç yangınlarında sıcaklık 2000 derecenin üzerinde olduğundan sürekli egzoz devam etmesiyle toksik gazların yangın ve duman damperi teknik tarifi nasıl değişecek? Sunum için teşekkürler demiş. So I think this question is about the electrical vehicle fires, and we have to consider this in the auto parks.
Yeah, no, I didn't get the whole question really.
So the question is that the electrical vehicle fires
Oh,
can
yeah.
go up to
Okay.
can go up to 2000 degrees centigrade.
Yeah.
So and they give continuously exhaust gases or toxic gases. In this case, if the fire and smoke damper technical specifications, how they will be changed, because it is quite new in our life, you know.
Yeah.
But I think this question goes to the closed parking areas.
Yeah. This is an interesting question. I just was on a seminar a couple of weeks ago where they're talking about car fires, especially also electric car fires. There are some differences between standard car fires and electrical car fires. But there are also some similarities, because a lot of people think that the energy of electrical car fire, an energy which is set free, is much higher than of a standard car fire, which is not true. If you look at the whole duration of the fire and look at the energy, it's the same. What you see in electric car fires, it's really a peak. The fire starts really very rapidly. It's not an explosion, but it's almost an explosion. The energy peak goes up quite high, very fast, but then it goes down again quite soon. And the fire of a standard gas car goes up a little bit slower, and then it goes down also slower. So from the energy point of view, there is not a big difference. I think it will not have a big impact on the fire damper specification, classification, or the smoke control system. What the other point is that for the extinguishing, so for the firefighter, fire brigade, it's a big difference, because extinguishing a standard car is quite easy. They're used to that. It's not a big problem. But extinguishing an electric car is quite a problem, because when you try to extinguish with water, for example, the water, you have no access to the battery where you have the big power stored. That's the problem. What you can do is just cool, more or less. So you need a lot more water for the cooling. And then you need to pull the car out of the garage and to put it in water, more or less. Well, for example, what they have here, the fire brigade in Zurich, they have a big container with water. They fill it and put the car into that container for roughly 2 weeks. That's what they do here.
Well, it's a dangerous issue. I think it's being discussed, and TÜYAK is going to have another, working time in end of October, I think, for this issue.
Yeah.
Okay.
That's interesting.
Yeah. Because it is a lot of movies, real videos are showing that it is quite dangerous and cannot be stopped and so on. So we have also had some papers about this, and it is really a new issue that we have to fight for.
Yeah. What you see, when you look at some example of fires in car parks, what you see a big difference is also when you have an electric car, this car stays where it is and the fire stays where it is. If you have standard cars with petroleum gas, the tank is made of plastic, some sort of plastic. And this tank is melting. And then the whole gas drops to the floor and spreads on the horizontal level.
Mm-hmm.
Then it usually spreads on the horizontal level to the next cars and the next cars. And the fire distribution on the horizontal level of standard cars is usually bigger. Depends a little bit on the space you have between the cars and things like that. But it's like a chain effect sometimes, going then through the whole car park.
Coming to our subject, then if the energy, if you say that almost the same, so nothing changes in the fire and smoke damper specifications as of today.
Yeah, I don't think that something will change.
Okay. There is no questions on the table, but I have another question to you while listening, because you are manufacturer of the fire dampers for both or for many markets, UL dependent markets or EN dependent markets. So are your motors for the fire dampers are the same models, or maybe the coding, the model numbering is different, maybe different, but are they the same, or is there any difference in between UL market and EN market?
That's a good question. So we manufacture actuators, and the actuators for the European market, but also including, for example, Russia, all the GOST requirements, some very local requirements are the same. And the actuators for the UL markets are different. They are specially designed for conformance with the UL standard. So we have two groups actually: the UL standard actuators and the European standard actuators.
What is the main difference? I mean, the torque or the time, opening or closing time?
It's torque, it's running time, because they have different regulations are asking for different running times. And on the UL side, you have the so-called elevated temperature tests. So the actuator, after half an hour exposed to 250 degrees or 350 degrees Fahrenheit, you still must be able to move the actuator or the damper to a certain position. And that's something we don't see on the fire damper side in Europe.
Mhm.
And on the smoke control solution in Europe, we have also a little bit a different situation. There are some applications which the fire brigade also must be able to control the dampers in a full developed fire, and there we use a thermo protection housing. But even in the housing there, you have temperatures going up to 100 degrees, and also there actuators have to operate.
Mhm.
And so the requirements are a little bit different, and therefore the design is different.
Connected to this explanation, another question, for example, for the smoke dampers. In European standards, the motors are asked to be in the box. But in UL, there is no regulation like this. So I think UL asks for damper motor resist to 350 centigrade Fahrenheit, 177 centigrade, I think, for 30 minutes, and it is enough. Is that correct?
Yeah. And here, do you still see my slide? Yes. So you see here on the smoke control side,
Yes.
you see different constructions.
Yes.
One construction looks actually like a fire damper, and there you see that the actuator is not protected. This is the so-called automatic activation solution. That means this smoke control damper is activated very early in a fire by the smoke control system, and just operates once. So the temperature are still low, it can be operated, and then the actuator has just to hold the damper in its position, either open or closed, during the whole duration of the fire. And the one here on the left-hand side is fully protected. So this is really a solution, which also the damper is made not of steel, so of calcium silicate. And you see the actuator, maybe also some interface electronics to a bus system is protected by this housing. And this installation is different from the first one, because this installation really can be operated by the fire brigade for typically half an hour, but then the temperature is standard time temperature curve. So you can have almost 1000 degrees C outside of the damper. You can still operate it for this half an hour. So it's a little bit a different requirement than in the US.
Mhm. Thank you very much.
You're welcome.
If there is no, I don't see another question. So I would like to thank you for your presentation and contributing to
Very welcome.
webinar. Thank you. Yeah, we are very happy to have you here.
Thank you very much for having me. It's a great pleasure for me as well. Thank you. And if questions are coming up from the audience, usually they come up in the evening having a nice beer. Please refer to my colleagues in Turkey, and they help you or they come back to me.
Okay.
I will be pleased to answer your questions. Thank you.
Teşekkürler. Değerli katılımcılar, hepinize çok teşekkür ediyoruz. Eminim yararlı bir sunum olmuştur. Başka sorularınız olursa yine bize TÜYAK aracılığıyla ulaşabilirsiniz. İyi günler diliyorum hepinize. Oturumu kapatıyoruz.
Bye bye. Thank you.
Bye bye. Hı hı.